So welcome to the next video in Unit 6, where we'll be solving systems of equations in three variables. Systems of equations possibly will be linear. I keep marking out the word linear because mostly if it has three variables, it's going to be a three-dimensional object, which is more like a plane instead of a line. So we'll solve systems of equations in three variables, and we'll look at, if not in this video, we will be looking at in class some real-world problems using, and then use the system of equations in three variables to solve them. So let's look at what this could look like if you have an equation in three variables. The equation of three variables is the equation of a plane, all right? And planes, just like in lines, we talked about lines can be parallel, right? No solution. Lines can intersect in a point, that's one solution. Or lines can just be the same line, and then that's all infinite solutions along that line. So those were the three possibilities if you had linear equations. Well, now we have planes, and planes are like the ceiling, or the floor, or the wall. So they're two-dimensional objects put together in a three-dimensional world. So it has two dimensions. So you can see here in this very first that this would be just like the corner of a classroom, right? You would have a wall, and then you would have perhaps the ceiling. And so all three of those, here's the ceiling, would be the corner of the classroom. And so all three planes would intersect in a single point. And because it's a two-dimensional object, it's actually going to have, the points will have three components, an x, y, and a z, because the planes together make a three-dimensional object. So another possibility for three planes, one is that they intersect in a point. The next one is that they don't all three intersect. Every two intersects. Like see here, you see two planes that intersect in a line. Here's the two planes, but they don't all three intersect. So this would be no solution. Another possibility is that all three planes are parallel. Once again, still no solution. And then another possibility is that the three planes intersect in a line, just like in a book, right? So down the spine of the book would be where the three planes intersect. And so this would be infinite number of solutions along the line, just like only three-dimensionally, but just like with lines. So we've talked about matrices in a previous lesson, and what we find here is that we can actually solve systems of equations using matrices. So as you'll recall from previous instruction that we have rows and columns. This is a 2x2 matrix. And if I were to write this matrix, I could write just the coefficients. And then I could also write a matrix of just the variables. And then I could write another matrix of the what it's equal to. Okay. And so another way to do this is like an augmented matrix, and that's where you just write it all in one. So I would have 2, 3, and then there's this little line there, 7, 0, 5, -3. And so this is a 2-row by 3-column matrix. This is a 2x2, this is a 2x1, this is also a 2x1. Okay? An identity matrix looks like this. So it has a 1, 0, and then a 0, 1. That looks like an identity. This is a 2x2. If you had a 3x3, it would look like this. Do you kind of see the pattern? So it just has the ones, and it has the ones in this diagonal right here. And those are called the identity matrix. Okay, so if we have three equations and three variables, we're going to write them, we're going to do a few of these where we write them as an augmented matrix. Okay, so you can see this is 3 rows, 4 columns. And so I'm going to just write just the coefficients. So I have 2, -1, 2, and then 15. And that's the first equation. So you can see that -1, right? There's not really a 1 there, but it's understood to be 1, a 2, and a 15. So here, this would be -1, 1, and 1, and 3. This is 3, -1, 2, and 18. So that would be a matrix written as augmented. Okay, so if I were to, what we're going to do is we're going to actually use row-reduced echelon form, and this is in our graphing calculator. And so what we're going to end up having, calculator, is that when we're finished, we're going to end up with a solution matrix that looks like this. It's still augmented, right? But it's going to have 1, 0, 0, 0, 1, 0, 0, 0, 1. So this part right here is the identity matrix. This is how I know it has one solution. And then there'll actually be numbers here for this one, and this one. Sometimes they're whole numbers, and sometimes they are fractions or decimals. It depends on what mode your calculator's in. But say, for instance, that the above matrix solved to be -2, 1, and 3. Then this would be a matrix that, or a set of equations that intersects in one point. And further, this would be like x, y, and z. So x would be -2, y would be 1, and z would be 3. Now that's not how you write it, because 3 planes that intersect in a point would be written as a point. So it looks like this. And so that's what the solution would look like. Now, there are other forms of what the solution looks like, and we'll talk about those in class when they happen. But obviously, if they're parallel, you're going to get something happen. If they intersect along the same line, you're going to have some things that happen as well. So basically what I want you to do at the end of this video is to be able to write the augmented matrix. We're going to spend time in class learning how to enter the matrices into your calculator. There's a matrix function, but for the first part I want you to write the augmented matrix. And to me it's easier to write them in rows, but I have some that'll write them in columns. But here's row, so I have a 5 and then a 3 and then a 2. Notice no letters, just the numbers in front with a 2. Okay, and then I have 2, then 1, then -1 and 5, 1, 4, 2, and 16. And so that is the augmented matrix. And this is a 3 by 4 matrix. So here is the last one, and I want you to write the augmented matrix in your composition notebook. And then what I want you to do is I want you to also take an augmented matrix, and I want you to write the equations. Okay, so I want you to take that matrix and I want you to write them as the equations. So write the augmented matrix and then write the equation, the system of equations. Okay, and I will see you in class.